Let's go over question number 11. Example 9.1 found on page 377. The example says complete the following nucleophilic substitution reactions. In each reaction, show all electron pairs on both the nucleophile and the leaving group. Okay, so let's go over A. Let's identify which one is the nucleophile and which one is the leaving group. So the bromide will be your leaving group. This will be your leaving group. So we will have it as having 4 lone pairs and a full negative charge. To counter the charge, let's just put the sodium ion. But if you leave it like this, I will count it right, just the Br with the negative charge. And the methoxide ion, this is your nucleophile. Methanol is just acting as your solvent. So the instruction is telling you that this is a nucleophilic substitution. So that means that you are substituting the leaving group, in this case Br, with your nucleophile. So count the carbons, 1, 2, 3, 4. So your product would have 1, 2, 3, 4. But instead of Br, we're going to have the O and CH3, the nucleophile. And let's go ahead and include the lone pairs. For the haloalkane, we have here 3 lone pairs for the Br. For the methoxide ion, this oxygen, because it has a negative charge, we have 1, 2, and 3 lone pairs. The oxygen here has 3 lone pairs, but once it's attached, has a bond with the carbon, it will now have 2 lone pairs. Let's take a look at the next reaction. It's telling you that it's a nucleophilic substitution reaction. So what you need to do is to identify the leaving group. Cl is the leaving group, and the ammonia, this is your nucleophile. Nucleophilic substitution, meaning that you will replace the leaving group with the nucleophile. Let's add the lone pairs. This halogen will have 3 lone pairs, and the ammonia, because it has 3 bonds with the hydrogens already, it's just going to have 1 lone pair on the nitrogen. And count the carbons, 1, 2, 3, and 4. So draw 4 carbons, 1, 2, 3, and 4. But instead of the Cl, you're gonna have the NH3. And because you have 4 bonds now attached to the nitrogen, 1 and the 3 coming from each of the hydrogens, then you will end up with a formal charge of +1 on the nitrogen. And the leaving group is the chloride ion. And you can use this to counter the balance of the nitrogen. Let's take a look at the next question, question number 12. And for question number 12, we have problem 9.1, also found on page 377. The instructions are the same as for the example 9.1. It says complete the following nucleophilic substitution reactions, and for each reaction you need to show all electron pairs on both the nucleophile and the leaving group. Okay, it's telling you that you have nucleophilic substitution, meaning you will replace the leaving group with your nucleophile. So for each of these 3 reactions, the halogen is your leaving group, And what you have here on top of the arrows, those are your nucleophile. So let's go ahead and add the lone pairs first for each of the reactions. Here you have for the Cl 3 lone pairs. For this you also have 3 lone pairs, and for Br you have 3 lone pairs. Alright, oxygen. Oxygen up here has 2 single bonds, meaning just one double bond, and because of that you will have just 2 lone pairs. The oxygen here has a negative charge, meaning that you have 3 lone pairs on the oxygen. And if you want to double check, then just go ahead and calculate the formal charge. If you do that, you will have the negative charge. The same goes for S, is found on the same group than the oxygen. So that means you will have 3 lone pairs. And for this carbon that has a triple bond, now is an anion, you will have 1 lone pair, just like you did for chapter 7. Okay, now again, we have nucleophilic substitution reactions, meaning you will substitute the leaving group with your nucleophile. This is the nucleophile for this reaction. This is the nucleophile for the second reaction. For the last reaction, this is your